Today we're going to be talking about angle and side relationships. I want you to take a minute and observe the sides and the angles and the measures of each and see if you can figure out a relationship between the size of the angle and the size of the sides. Press pause, and when you're ready to hear the answer, press play again. All right, what I want you to notice is that the largest angle is across from the largest side. So if I look at this triangle here, this is my largest angle, and across from it is my largest side. Likewise, my smallest angle is here, and the smallest angle is across from the smallest side. And we have a nice theorem that goes along with this. The angle-side relationship says if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So if you look at this picture, my hypothesis is that AB, my side here, is bigger than BC. So because of that, I know that angle A is smaller than angle C. The converse works as well. If two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So my hypothesis is that Z, that's my biggest angle, is bigger than angle Y. So the side opposite Z is the largest side, and the side opposite Y is the smallest side. Take a minute, pause your video if you need more time to copy that down. Now, here are a few examples. I'm going to do the first one with you, and then I want you to do the second two. The first thing that I need to do in order to determine what is the longest side and what's the shortest side is to figure out the third angle. And I know that interior angles of a triangle sum to 180. So I'm going to subtract 41 from 180 and subtract 95. That tells me this angle here is 44. Again, I'm taking 180 degrees, I'm subtracting 95, and I'm subtracting 41. That is this angle. Now, I'm going to label the angles in my triangle S, M, and L for small, medium, and large. Here's the S, here's the M, and here's the L. And then I know across from my largest angle is my largest side. Across from my medium angle is my medium side. And across from my small angle is my smallest side. So if I want to list the sides from shortest to longest, it would look like this. AB is less than BC is less than AC. Press pause, and when you're ready to see the answers for 2 and 3, press play again. And here are the answers. Now, in the second one, I would list AC first, I would list AB second, and BC third. In the third problem, AB is the shortest, BC is the next shortest, and then AC finally is the largest side. Now, the next thing I'm going to do is, given the sides, determine which angles are smallest and which ones are largest. So we're going to do the first one together, and then I want you to do the second too. Again, just like I did before, I'm going to label my sides small, medium, and large. In this case, I have two that are exactly equal. So it's an isosceles triangle. But now I know, since these two sides are smaller than my base, angle B and angle C are both the smaller of the three angles, and then angle A is the largest. So if I name my angles in order, I would say angle B is equal to angle C, and those are should say the measure of each, and those are less than the measure of angle A. Press pause on your video when you're ready to see the answers on 2 and 3, plus press play again. Here are the answers, and again, we are going to list the angles from smallest to largest. In my second one, the measure of angle B is less than the measure of angle A is less than the measure of angle C. For number 3, the measure of angle A is less than the measure of angle C is less than the measure of angle B. Now, when I'm given 2 triangles and they share a side, I am able to find the side lengths of all of them in order. Now, let me show you the procedure that works for this. So I've got to find all my angles. I'm going to look at triangle ABD first. Again, I need to take 180, subtract 75, and subtract 70. That tells me that angle A is 35 degrees. Now I'm going to look at triangle DBC. And again, 180 minus 80 minus 40 tells me that this angle is 60 degrees. Now, just like I did before, I'm going to label my angles small, medium, and large. I'm going to look at each triangle separately. This one's my small angle. This one's my large angle, and this one is my medium angle. So across from my medium angle is my medium side, across from my large angle is my longest side, across from small is my smallest side. Now you'll notice that this is the small side. BD is the small side of the first triangle. Now let's see how it works out over here. I'm going to use a slightly different color. Now, here, my smallest angle is 40 degrees, so I know that this is my smallest side. My largest angle is 80 degrees, so that is my largest side. And my medium angle is 60 degrees, so that is my medium side. Again, remember, the largest angle is across from the largest side for all these. I'm talking about the angles that are across from the sides. Now, if I look at my right-hand triangle, side BD is the largest one, so that means that DC and BC are smaller than that. But BD is the smallest segment of triangle ABD. So this one on the outside, DC, that's the smallest segment. If BD is the largest segment of this triangle and it's the shortest segment of my left-hand triangle, that means that every side in here must be shorter than are in my left-hand triangle. Now, the procedure, if I label it like this and I look around the outside of my shape, I can find the small first. Find the side that goes with S on the outside. Then you know which triangle you're beginning with. I'm going to begin with this triangle, and then I'm just going to go in order. This was my small side of my purple triangle. My next biggest is BC. That's my medium side. And then my next biggest is BD. Now, that will allow me to cross over into the next triangle, to my red triangle. So BD was the shortest side here. So the next largest side is AB. And then finally, the largest side is AD. Now, a triangle is formed by 3 segments, but not every set of 3 segments can form a triangle. Segment lengths of 7, 4, and 4 can form a triangle, but segment lengths of 7, 3, and 3 cannot form a triangle. And that is because if you look at that segment that's 3 long, there is not any way that you can connect them without laying on top of itself. So like if I try to move this segment that's 3 in as close as I could so that it could match this other one, they would never touch. So from this, we have a theorem that tells us what kinds of segment lengths can form a triangle. It says the sum of any two side lengths of a triangle is greater than the third side. So if you look, this segment plus this segment, AB plus BC, has to be greater than AC. Okay, and you can also think about it this way. If you have a choice between, let's say this is the school, and then your house, and this is dog tracks. It is always faster to go straight to your destination. As soon as you make a detour, it's a longer drive. And that's all this is saying, is that the sum of the two side lengths has to be greater than the third. Now, if you need more time to copy this down, please press pause, and when you're ready, press play again. Now, I want to look at this and tell whether a triangle can have the following side lengths. So, in order to do this, I add my two smallest side lengths together and compare it to my largest. So 3 plus 5 is 8, and that's greater than 7. So yes, it can be a triangle. But in this case, I'm going to take my two smallest side lengths, 4 plus 6, that's 10, that's less than 11. That cannot be a triangle. So it has to be greater than, it can't even be equal to. Now I'd like to know the possible side lengths for a triangle that has the following two side lengths. I have 4 and 10. Now the first thing I like to do is draw myself a picture. So I know that the sum of my two side lengths has to be greater than the third no matter what. X plus 4 has to be greater than 10. I know that x plus 10 has to be greater than 4. And I know that 4 plus 10 has to be greater than x. So in each of these, I'm going to solve for x. X is greater than 6, x is greater than negative 6, and 14 is greater than x. But I generally like to write it with my x on the left. It makes it easier to read. Now, you can picture your number line. Ooh, that's not a nice line. Let's try it again. Picture your number line. I'm going to put my key values on here. I've got 6, 14, and I've got negative 6. Let's extend this a little bit. Okay, so I know that I have to have a value that's greater than 6, and I know that I have to have a value that's greater than negative 6, and my values have to be less than 14. And my goal is to find out where all three of those things are true. And you'll notice that all those possibilities intersect there. So x has to be between 6 and 14. There's a nice shortcut that goes with this. 6 is all, you're going to have the difference of my side lengths. The third side length is between the difference of the side lengths and the sum of the side lengths. And that will always work, but I did want you to understand why. Now, that will only work when you're given values, but if I'm given expressions, it works out a little bit differently. So I have to compare these. I have to add each of the two sides and set it greater than the third. So the first inequality I'd have would be x plus 8 plus 3x plus 5 has to be greater than 4x minus 11. I know that 3x plus 5 plus 4x minus 11 has to be greater than x plus 8. And then I also know that x plus 8 plus 4x minus 11 has to be greater than 3x plus 5. I need to solve each of these. So this would be, that would be 4x plus 8 plus 5 is 13. It's greater than 4x minus 11. If I subtract 4x from both sides, I get 13 is greater than negative 11. This is always true, so that's great. I don't need to worry about that one. Here I get 7x minus 6 is greater than x plus 8. So we'll subtract x from both sides. That's 6x is greater than, add 6 to both sides, 14. Divide both sides by 6, x is greater than 7/3. Over here, I get 5x minus 11, 8 minus 11 would be minus 3, is greater than 3x plus 5. Subtract 3x from both sides, that's 2x. Add 3 to both sides, that's 8. X has to be greater than 4. So 7/3 here is really 2 1/3. So I know that x has to be between 7/3 and 4. That is our lesson for the day. Check online for your assignment, and the answers are posted there as well. I'll see you tomorrow.